In order to support the execution of software, we need a processor and a memory. Let's add the processor and the memory components to our system. Just like with any other component, you specify the component type and its name. If necessary, add the component implementation. Add the memory as a subcomponent of the processor. The memory is where the executable code is stored, while the processor is where it will be executed. A bus is required to carry data and control signals between physical components. While ports were used to establish data and event exchange between both hardware and software components, a bus will be used to establish communication from several hardware components to the processor and memory. Don't forget to add the processor and the bus as subcomponents of our system. Instead of adding these components, you can actually add their specific implementations. For example, I will add my processor implementation, and that way I know that the memory also becomes part of the system because it is a subcomponent of my processor implementation. The bus will be connected to each hardware component, including all our devices and processor. In AADL, a bus access is categorized as one of the features. So first we specify the bus access feature in each device. For example, we give the bus access name, use the words requires bus access, and provide the bus name we are connecting to. Add the bus feature to each device you want to connect to the bus. Also add it to the processor type declaration. We need to specify the connections in the top-level implementation of our system. Each connection can have a unique name, just like we previously did it with ports. Use the words bus access to show which type of connection you are specifying, and type the bus name as it appears in this implementation. Arrow, type the device name as it appears in this implementation. Dot, the name of the bus access feature. Now you can do the same for the remaining 4 bus connections. Now you can see that the processor has been connected to the hardware devices through the bus. I will rearrange the position of components in the graph to prevent the lines from crossing each other. In the next tutorial, we will add and schedule threads, which will be responsible for executing the software in our system.